Good morning, everyone.
Good morning, sir.
Good morning.
My screen and voice clear?
Yes, sir.
So good morning, all. The mid one is stated to start from the next Monday, that is August 2nd. Okay. The timings allotted for our campus are after 2 p.m. Okay. Because in the morning sessions, the other two campuses will be having examinations, and the Moodle right now can only handle 1,000 requests at a time. So our campus is allotted slot in the afternoon session. So that's a little bit of cheer to me, as no flat session will be disturbed in the entire next week. So we have requested HOD CSE to hold the last possible slot for the subject flat, but same is the case with the other subjects as well. Many of the syllabuses are lagging behind. Okay, so I'm not sure whether we will be given the last slot or not, but a request is sent from the faculty side. Still, there are some 3 to 4 concepts first that need to be covered. Okay. Yeah. So we are done with DFA, the most basic machine, and we are done with NFA, a somewhat flexible machine. And in the previous class, we have seen NFA to DFA conversion. I hope you are a little bit clear on these 3 concepts at least. So given a kind of problem, I hope you can able to construct NFA, a bit of DFA, and the NFA to DFA conversion as well.
Yes, sir.
So moving ahead, the next topic is Epsilon-NFA, the third of the without output machine. So you have seen the finite automata classification, right? Without output and with output. Without output, again, we have 3 ones. So that is DFA, NFA, Epsilon-NFA. So this is the third one we are dealing with. With output, we have 2 machines, Murray machine and Mealy machine. Okay. So DFA done, NFA, NFA to DFA. Now we are in the third machine, that is without output. So the third automata machine, Epsilon-NFA. It simply it is written like this, Epsilon-NFA. Okay. So first point is it is also an automata machine without output. Okay. So it is also finite automata without output. Right, and it is also having 5 tuples. What are the tuples, guys?
Q, sigma, delta, Q0, and F.
So the 5 tuples are same for the first 3 automata machines. The only difference is with the mapping function. Okay. So for DFA, the delta is Q cross sigma is Q. For NFA as well as Epsilon-NFA, the transition function is Q cross sigma is 2 power 2. That means in DFA, from one state on one input, we can reach only one state. In NFA and Epsilon-NFA, from one state or an alphabet input, we can reach more than one state. Don't know, I mean, we're not that bothered about what will be the value of exact value of 2 power 2. It will be somewhat greater than 1. That's what we require. So this is the basic mapping difference of the transition function for the DFA and the NFA parts. Okay. Now, in Epsilon-NFA, there is one property or one rule you should be very, very aware of. That is, every state on the input epsilon reaches itself. Okay. So in Epsilon-NFA, it's not the case with the DFA and normal NFA. Okay. In Epsilon, Any doubts?
No, sir.
Yeah. If not, kindly mute yourself. Ma. There's a bit of disturbance to me. Okay. Yeah. I think still some need to be get muted. Ma. Okay. Yeah. So in epsilon NFA, it is an important property. Every state on the input epsilon reaches itself. Okay. Even though it is not depicted in the question, or if the data is not given, this is the one property you should know. Ma. Every state in epsilon NFA over the input epsilon reaches itself. Okay. Now I will show you one basic epsilon NFA diagram. Ma. It's more or less like a similar NFA. So Q naught on 0, Q naught on epsilon is Q1, Q1 on 1 itself, and Q1 on epsilon again it is Q2, which is final state, and it goes to itself on the input. Okay. So this is a basic epsilon NFA. Now you can ask me, sir, for NFA, there should be more than one input from one state to reach the other state. But upon mere observation, it appears as a simple DFA. You might be getting that out. But that's why I have iterated this point. In epsilon NFA, every state on epsilon reaches itself. That means even though epsilon is not given for Q naught, there will be a virtual epsilon you should be assuming. So Q naught on 0 goes to itself. Because of the property, there will be an epsilon also for Q naught over Q naught. So in a sense, you see, now it has become NFA. So Q naught over epsilon, it's going to Q naught, as well as Q naught over epsilon, it is going to Q1, thereby satisfying our NFA problem. So the same is the case with Q1 also. There is a hidden epsilon over Q1 also. So Q1 on 1, Q1, also Q1 on epsilon is also Q1. You see, two inputs, two states. Okay. So that's why it is an NFA. So such kind of tricky questions can also be asked. Given this kind of NFA without epsilon, they ask you whether it is a DFA or NFA, or you can say why not it is DFA because it's having distinct inputs. So you should quote this property. In epsilon NFA, every state on epsilon reaches itself, given or not in the description. So it is NFA over epsilon. It is going to itself as well as other states as well. Okay, so even though it is not given, you should take this data. Okay, so this is a simple demonstration of epsilon NFA. Now coming to the exam point of view, the questions that can be asked over the epsilon NFA are three models. We have three models of questioning for this thing. 1 second, guys. Yeah. So the first methodology is string acceptance. Okay, so over the epsilon NFMA, you are given an input string and you are check whether the string is accepted or not. Okay, and the second methodology is epsilon NFA to a normal NFA conversion. We have seen NFA to DFA conversion, right? Also on the similar lines, you are given an epsilon NFA as such and you are asked to convert it to NFA without epsilon transitions. So this is one kind of conversion, and we can also have epsilon NFA converted directly to DFA also, bypassing NFA. Okay. So these three are the types of questions that can be asked over the concept epsilon NFA. So the first one is very basic, string acceptance. So let's say for the same epsilon NFA, they're asked to check whether the string 0, 1, 2 is accepted or not. Okay. Remember, in case of string acceptance, all you need to do is you start at initial state You take one input character at a time, no? Because I have told you all the finite automata, it can scan only one input at a given point of time. It cannot go over two inputs simultaneously. So start from the initial state, take one input one by one. At the end of the last input string, you should be at the final state. So only then you can call the string to be accepted. If you start from initial state, you scan over the input. If you are not reaching the final state, or if you are stuck at some other intermediate state, then that string is not set to be accepted. Okay, we can start from initial state or any intermediate state as well. Okay, but most of the cases it will be initial state. Na? You have to traverse input one character at a time. At the end of the given string, if 0, 1, 2 is asked, so after the traversing of the input 2, you should reach final state. Only then you can call the string to be accepted. If you are not reaching final state, yet the input is traversed somehow, you cannot call it as a successful case. Okay, you have to reach the final state as well as the input need to be traversed. Okay, so this type of string acceptance questions are the most basic form of asking the questions over Epsilon-NFA. These two are, as you know, because of the conversion, the process is somewhat lengthy and somewhat tricky as well. Okay, so now I'll start with the first methodology, that is Epsilon-NFA string acceptance. So Epsilon-NFA with string acceptance. The same NFA, Q0, 0, epsilon Q1, 1, again epsilon Q2, final state 2. Okay. Now I want to check whether the string 0, 1, 2 is accepted or not for this NFA. Now, file the string acceptance, step 1. Okay. In the first step, all you need to do is compute epsilon closure. Okay, compute epsilon closure. Now, what is this epsilon closure? So this is a small concept you need to study for Epsilon-NFA. So I'm explaining the definition. Epsilon closure is a set of states, okay, that can be reached from a state, over the input epsilon. So this is the definition of epsilon closure. I'm reiterating again. So epsilon closure is a set of all the states that can be reached from a state over the input epsilon, not other inputs. Okay. For example, epsilon closure of Q0. Watch this carefully. Epsilon closure of Q0. If I want to compute in this NFA, if I want to compute epsilon closure of Q0, see the definition: set of states that can be reached from a state over epsilon. So Q0 from this NFA, you can see there is only 0, but I have told you there is a virtual epsilon, right? Every state over the input epsilon reaches itself. So from Q0, if you take the input epsilon, you can reach Q0. Agreed, all of you?
Sir, once more.
There is a property in Epsilon-NFA that I have just discussed now. Every state in Epsilon-NFA over the input epsilon reaches itself. So although it is not shown, see the case of Q1. So only we have a path 1 over Q1, but actually there is another hidden epsilon. So in Epsilon-NFA, for every state, there is a epsilon over itself. Every state over the input epsilon, it reaches itself. So some cases you might have like given the data like this, even though it is not given, you should take it as. Okay. So coming to the epsilon closure now, what is epsilon closure? It is set of all the states that can be reached from a single state over the input epsilon. So if I'm computing epsilon closure of Q0, so set of the states that can be reached from it via epsilon. So from Q0, if I take epsilon, I can reach Q naught also, right? Atharva, clear?
Yes, sir. Yes, sir.
Okay. Now, from Q naught, if I take epsilon, I can reach Q1 also.
Yes, sir.
Now, the epsilon closure is like a contiguous path. It should not break with Q1. So you see, from Q naught, if you take epsilon, you can reach Q1. From Q1, if you reach, if you take epsilon, you can reach up to Q2, right? That means from Q naught to Q2, there is a path over epsilon, right?
Yes, sir.
So Q2 will also come. So is there any other path after Q2? Ma?
Q2 itself.
Yeah, that is already entered, right? Is there any other new state?
No, sir.
No, that's it. So epsilon closure of Q naught is Q naught, Q1 and Q2. Ma. So from Q naught, if you take the input epsilon, these are the states that you can reach. Clear all of you?
Yes, sir.
Now, epsilon closure of Q1. Now you tell me, guess, what will be the epsilon closure of Q1?
Q1 and Q2.
So we are computing epsilon closure of Q now Q1. Ma. So Q1 on epsilon, it comes to itself. So Q1, and there is a path from Q1 to Q2 over epsilon. So Q2. See, many of the students confused here. Ma. They see epsilon in between Q0 and Q1, and they are Q0 mistakenly. You see the directional errors. That's why I have told you the importance of direction. There is a path from Q0 to Q1 over epsilon, but the same is not the case vice versa. There is no path from Q1 to Q0 over epsilon. So if you forget the direction, simply in the hurry of the examination, there is a healthy chance for you to write Q0 in the place of epsilon closure of Q1, which is not the case. So that's why please be very, very careful with the arrows. So sometimes what happens is in the flat, the main cement examination, previously in the descriptive type, because of the printing errors and all, there will be no arrow braces. Okay. So at the time, if you have any encountered such issue, what your senior students used to do is you simply call the invigilator and inform the issue. There's no path and all these things. So we, the flat faculty, used to resolve the issue. Okay. My suggestion is, if the same happens to you, if no resolution comes throughout the course of hour, you do attempt that answer. Okay, because there's a healthy chance for you to get full marks for that because of the error from the printing side. Okay, but mostly that's not the case, ma. So you need to be very careful with the directions. Okay, so epsilon closure of Q1 is Q1 as well as Q2, but not Q0, because there's no path from Q1 to Q0 over epsilon. Okay, in the same way, epsilon closure of Q2. What are the states?
Q2.
Only Q2, right? There are no other states. So epsilon closure of Q2 is Q2. Okay. So this is the step 1. In the Epsilon-NFA, compute epsilon closures and write aside this first step. Step 2. Step 2 is compute the transition functions. So step 2 is computation of the transition function. Just a second, guys. So the step 2 is computation of the transition function. So transition function is nothing but delta. So this transition functions corresponds to the given input 0, 1, 2. So this is our input that need to be checked, right? So I start from Q0. Why? Because what is the mode of delta? Q cross sigma is 2 power q because of the NFA. So always for delta, you should take like this. You should take a state. You should take an input alphabet that should map to one state. Okay, so delta Q0 comma, I'm taking the first character of the input 0. Okay, because this is a finite automata that can scan only one character at a time. You should not take 0, 1, 2 as a whole. Take the first character, delta Q0 comma 0. Now, can I write the same like this? Delta Q naught comma 0. Can I write it as epsilon 0? Ma? Is there any difference? Are they both the same or is there any difference?
Different. So
What is the difference?
0 have some value, right, sir? But epsilon is a null.
Epsilon?
It's a null, no, sir. Null.
Okay, that's what I'm asking. That is that epsilon brings any significance difference to these two?
Yes, sir.
What is the difference?
0 is not equals to epsilon, right, sir?
0 is not equal to?
Epsilon.
I have told you epsilon is a null string that don't have any value or neither it is a length 0. Then what difference it will bring whether it have add 0 or epsilon 0?
It reaches different states, sir.
It reaches?
Different states. The Q naught with 0 will reach Q naught, but with epsilon it's reaching Q1 and Q2.
Okay, so you are thinking it in the directional perspective, right? Okay, ma. Don't dwell too deep into this. Just for our problem understanding, kindly do make note that both are one and the same. Ma. Okay, we are only worried about epsilon as whether it is having some length or some value. But as we discussed, epsilon is a null string. Okay, it doesn't have any value nor it has anything. So just assume that we are using it for our computational convenience. You have seen in your +2 mathematics and all these things, right? Division and multiplication with same number just in order to cancel the value. Addition with 0, multiplication with 1. All this we used to have for computational convenience, right? So in the same way, just assume that Q naught on 0, I am appending epsilon. Okay, don't just go with all the states and all. We need not worry about this thing. Just see this. Just assume that Q naught on comma 0 is same as Q naught comma epsilon 0 because we are only taking epsilon as a null string. Okay. Now, actually, this delta itself is epsilon closure now because we are computing Epsilon-NFA. So the transition function is epsilon closure of Q naught comma epsilon 0. So epsilon closure of Q naught comma epsilon comma 0. Can I write like this? I can split the two inputs into two different characters, right? A comma B is A comma B comma C, the basic of set property. So just for my computational convenience, I'm just splitting the input as 2 and I'm giving epsilon to Q naught. Clear all of you? Are you getting?
Yes, sir.
Okay. So now it is epsilon closure of.
Sir,
Q
can you
naught on
explain this one once again?
this second step.
Yes, sir.
Okay. So are you clear with the step 1?
Yes, sir.
So for this problems, Epsilon-NFA with string acceptance, first thing is you need to compute epsilon closures. So we have computed epsilon closures. Keep it aside. Step 2 is you should start with the transition function. So transition function, you take the initial state of NFA, that is Q naught. You take the first input character. My input string is 0, 1, 2. I should take the first character 0. So I'm writing Q naught comma epsilon 0. I'm just assuming null string, it won't change any significant difference to it. Okay, just I'm adding Q naught comma epsilon 0. Okay, for all this, the transition function will be epsilon closure now because we are starting, we are all, anyhow dealing with Epsilon-NFA. So delta of Q naught comma 0 is epsilon closure of Q naught comma epsilon 0. This is the formula. So epsilon closure of, I can append like this, right? Q naught comma epsilon comma 0. I'm splitting the character, the input into 2. I'm giving it into Q naught, only the epsilon, and then I'm keeping aside 0.
Sir, what is epsilon 0? I didn't understand.
What is?
This epsilon 0 thing, what is that, sir?
The same as difference between 5 and +5. Both are one and the same. Q0 comma 0 and Q0 comma epsilon 0 are both one and the same. I'm just appending it for my convenience. That's it.
Okay.
So now it has become epsilon closure of Q0 comma epsilon comma 0. So again, we have some formula. Q0 on epsilon is nothing but epsilon closure of Q0 comma 0. Now, epsilon closure of, what is epsilon closure of Q0? Ma? What is the epsilon closure of Q0?
Q0, Q1, Q2.
But don't get
Q0,
confused. No?
Q1,
Once
Q2.
we get into the second step, you can get the clarity of how exactly the things will proceed. Okay, just don't worry. Just see this step. So epsilon closure of Q0, we already have a value. Ma. Q0, Q1, Q2, comma 0. Now, this is Q0 on 0, union Q1 on 0, union Q2 on 0. Okay. Now, this thing is epsilon closure of, what is Q0 on 0, ma?
Q0 only.
Q0 on 0, it is going to Q0. And what is Q1 on 0? Is there any path from Q1 on 0?
No, but
From Q1 on 0, there is no path. So 5. Is there any path from Q2 to 0?
no, sir.
No, 5. So it will be ultimately epsilon closure of Q0. What is the epsilon closure of Q0? Ma?
Q0, Q1, Q2.
Q0, Q1, Q2. So from initial state, if I take the input 0, this is what I had reached. Ultimately, I'm reaching Q0, Q1, Q2. Okay. Let me, right here. Now, what is the second input character? Ma?
1.
1. So already 0 is scanned, right? Now I'm taking the second character, 0, 1. Okay, I'm appending 1 to it, 0, 1. So this is epsilon closure of, I'm not writing the closure word because of the space constraint. So you assume it as epsilon closure of Q0, now 0, 1. So Q0 comma 0, 1. So epsilon closure of Q0 comma 0 comma 1. Or I can also view it as Q0 comma epsilon 0, right? Just now I have appended same epsilon here. I can able to append epsilon here also, right? So epsilon closure of Q0 of epsilon 0. I have computed all these things. Q0 epsilon closure of Q0 comma epsilon 0. What is the value?
Q0, Q1.
My step అర్థమైందా?
Yes, sir.
See, Q0 0, 1 second input. I had taken the second character of the input. Otherwise, are you following?
Yes, sir.
So the same formula is same. Epsilon closure of Q0 comma 0, 1. I'm taking the first step. Q0 comma 0. Instead of simple 0, I'm just appending epsilon. So it will be epsilon closure of Q0 comma epsilon 0. So previously I have computed epsilon closure of Q0 comma epsilon 0. What is my ultimate input? Sorry, output for this?
Q0, Q1, Q2.
Q0, Q1, Q2. So I'm writing here. Q0, Q1, Q2 over 1. Previously it is 0, now it is 1. So which is Q0 on 1, union Q1 on 1, union Q2 on 1. What is Q0 on 1? Ma? Is there any path Q0 on
Sir,
1?
2 minutes, sir, 2 minutes.
Otherwise, are you noting down?
So,
Yeah.
so here can we split epsilon and 0, sir?
Epsilon and
0.
where ma in the second step?
Oh, yes, sir.
I didn't get you. Like what kind of splitting?
Like in the previous one, we split epsilon and 0, right, sir? Like
Yeah.
this can't we split?
So in this, what you're asking?
So we can split epsilon and 0 to here, right?
You're asking to take only epsilon and 0, 1 in the outset, na?
Yes, sir.
Okay, even though the result will be same, but what I'm saying is if I take epsilon 0, readily I had a complete computed answer, right?
Yes, sir.
That's why I have taken this. You can also, I have got the question. So you're asking me to write like this and kept 0, 1 aside.
Yes, sir.
Still the same will come now. Q0 on epsilon, I have to compute the epsilon closure Q0, Q1, Q2. That for Q0, Q1, Q2, I will take 0 and 1 separately. Instead, what I will do is I will append 0 inside. For epsilon 0, I had already the computed value right now.
Yes, sir.
Both are one and the same. I am going the optimal path. That's it. Because I had a already computed value. That's it.
Okay.
You can also take Q0 on epsilon inside and 0, 1 at the offset. That is also yielding the same result. That's not an issue. But that will fetch 5 to 6 steps more of your time. Always go with the optimal path. I had a ready answer for epsilon 0. Why to take it only as epsilon and later computing with 0 and 1? That's it. But okay, that's also valid. You can go the same path. In set theory, everything is valid. A comma BC is AB comma AC, or you can take A comma B or C, or you can take A comma C with B. All these things are valid. Okay. So
Okay.
I'm taking Q0 epsilon 0, man, just because I had a ready value for it, which is Q0, Q1, Q2. So Q0, Q1, Q2. Now the output value, I mean, the external value is 1 here. Okay. So Q0 on 1, Q1 on 1, Q2 on 1. Now see, Q0 on 1. Is there any path now? Q0 on 1. Is there any path from Q0
No,
on
sir.
1? No, right? So it's 5. Q1 on 1.
Q1.
Q1.
So Q1 on 1, it's going to Q1. So we have a state Q1. Q2 on 1.
I.
5. Nothing. So it is ultimately epsilon closure of Q1. What is epsilon closure of Q1?
Q1, Q2.
Q0, Q1, Q2.
So we have a ready value, right? Q1, Q2. Okay, fine. Let me clear the space here. Now the third transition function. This is first delta Q0 comes 0, we have traverse. Delta Q0 on 0, 1, we have traverse. Now it is delta Q0 on 0, 1, 2. Right? Now I'm taking the third character. 0, 1 done. Now I'm taking the third character, which is 0, 1, and 2. Now this epsilon closure of Q0, comma 0, 1, 2, right? Now I will take epsilon closure of Q0. I will take 0, 1, 1. 0, 1, comma 2. Valid?
Yes, sir.
Why I have taken 0, 1?
Because already completed.
Already.
Yeah, same logic, the same optimal logic. Q0 on 0, 1, already we have a ready answer. What is the answer now?
Q1,
What is
Q2.
Q0 on 0, 1? It is Q1, Q2, right?
Yes, sir.
Comma 2. Which is Q1 on 2, union Q2 on 2. So now epsilon closure of what is Q1 on 2?
5.
I.
There's no path, right? Q1 on 2, there is no path. 5. What is Q2 on 2, ma?
Q2.
Q2. So it is ultimately epsilon closure of Q2. What is epsilon closure of Q2, ma?
Q2.
Q2. What is Q2 in our NFA?
Final state.
Final state. We have reached final state, right?
Yes, sir.
Can I say 0, 1, 2 is accepted?
Yes, sir.
Yeah. So for this Epsilon-NFA, the swing 0, 1, 2 is accepted. Now, still we have, I think, 8 minutes more. You try 0, 1, 1, 0, 1, 0, 1, 0, 1, and 1, 1, 0. This is your task. For the same Epsilon-NFA, check whether these 4 swings are accepting or not. The same methodology. Kindly do and tell me what are the swings that are getting accepted and what are the swings that are not getting accepted.
Sir, 011 is not valid.
So we are not reaching final state.
Yes, sir, not reaching.
Okay.
010 is also not reaching.
Very good. 0, 1, 0 is failed. Still. Otherwise, try for only 1, 2.
Okay, sir.
No. Try it for 0, 0, 2. The one girl student just now said 0, 1, 0 is not accepted. You try 1, 0, 2.
Okay, sir.
Okay, guys, just see once again. I'm just reiterating briefly. So this is the concept of Epsilon-NFA. So you will be given an NFA which has epsilon transitions. So this is the first model of asking. You are given a string and check whether that string is accepting or not. Okay. So this is the first step. Compute epsilon closures. Okay. So this is the definition of epsilon closure. From a state, what are the other states that you can reach? That you can reach over the input epsilon, not the other 1, 2 values. Only epsilon is to be considered. Such a set is called as epsilon closure. So epsilon closure of Q0. Let me change the ink so that I can pick one by one. So epsilon closure of Q0. See this. From Q0, you take epsilon, you reach Q0 because that is the rule. In Epsilon-NFA, every state on epsilon reaches itself. So I have Q0. Q0 to epsilon, there is Q1 path. So Q1. So from Q0 on epsilon, you reach Q1. Again, you take epsilon, you can reach up to Q2. So epsilon closure is like a longest path. So from Q0 with the help of epsilon, you can reach up to Q2. So Q2 is also reached. So the same the case of epsilon Q1. So from Q1, you take epsilon, you reach Q1, you take epsilon, you reach Q2. And finally epsilon Q2. Okay. Q2, you take epsilon, you reach Q2. So these are the epsilon closure. Keep it aside. Now you should compute transition functions. So transition function is nothing but delta. So what is the formula of delta we have discussed? So delta in Epsilon-NFAs, what should I write? Yeah, here. So delta is Q cross sigma to 2 power Q. That is from a state, you take an input, you will be reaching more than one state. So from a state, initial state Q0, which is initial. So this is the first step, guys. Now, yeah.
Sir, I have doubt.
Yeah, Dharma.
Sir, in 011, I guess I was wrong initially. I think it's accepted. Sir, because in the final, I'm getting epsilon enclosure of Q1 only. So if I just say Q1, then if I take the epsilon enclosure, it goes to Q2 also, right? So
Yeah.
it will be correct, no? It will be
Yeah, it will
accepted.
be correct. So at the ultimate
Ah.
last step, if you are reaching final state, then that you can call it as accepted.
Okay, so 011 is accepted, sir.
Okay. So that's why otherwise you should be very, very careful.
Yes, sir. I checked it again. Then I realized I did
Yeah,
something
that's why
wrong.
please a bit of patience for this kind of problems. Okay, you should see all
Yeah.
possible cases.
Yes, sir.
Okay. Yeah. So here, guys, delta Q naught on 0. I'm taking first input character. You should only take one by one because the automata machine is designed in such a fashion. So I'm taking 0. So Q naught comma 0, I will write it as Q naught comma epsilon 0 because both are one and the same. It is one formula. Okay, if we can have a debate, we can have it for whole day long. But let's not go down the track. Just assume for our convenience, I'm appending epsilon before to the input 0 just for my convenience. So by formula, it becomes epsilon closure of Q naught comma epsilon. So Q naught comma epsilon is epsilon closure of Q naught. This is again a formula. Okay. We need not study how the formulas have been derived and all this thing. Just we require it for the problem solving. That's it. So Q naught on epsilon I will keep and 0 I will keep aside. So Q naught on epsilon is epsilon closure of Q naught. So epsilon closure of Q naught is we have already computed Q naught Q1 Q2. So Q naught Q1 Q2. That over 0. That means this is a basic set theory concept. Q naught on 0, Q1 on 0, Q2 on 0. So Q naught on 0 will be reaching Q naught. Q1 on 0. So from Q1 in the original NFA over 0, there is no path. That is 5. Null. Not null, actually, it's 5, nothing. From Q2 to 0, Q2 to 0, there's nothing you can reach. So again 5. So ultimately, it is epsilon closure of Q naught because we don't consider 5s. Epsilon closure of Q naught. What is epsilon closure of Q naught? Q naught, Q1, and Q2. Okay. So this is the output of the first transition function. Delta Q naught on 0, I'm getting this thing. Okay. Now, this is 1. This is 2. See here. Now, as I'm done with the first input character 0, we take the second input character 1. Q naught 0, 1. So the same formula, epsilon of Q naught comma 0, 1. I'm splitting 0, giving it to inside. I'm giving it to Q naught. I'm keeping 1 aside. Okay. So just as in the previous step, for my computational convenience, I am appending epsilon prior to 0 because I have computed Q naught comma epsilon 0, which is same as Q naught 0. Okay. So Q naught comma epsilon 0 of epsilon closure, I have already computed previously. The value is Q naught, Q1, and Q2. So I'm just substituting the value here. Q naught on epsilon 0 is Q naught, Q1, Q2, comma 1, the input one. So it is Q naught on 1, Q1 on 1, Q2 on 1. So Q naught on 1, no path, 5. Q1 on 1, Q1 on 1 is itself. Q2 on 1, Q2 on 1, there is no path, 5. So ultimately it is epsilon closure of Q1. What is epsilon closure of Q1? See here, Q1 and Q2. So we have Q1 and Q2. Now come to third step. So 0 is done in the input, 1 is done. Now you take 2. So Q naught of 0, 1, 2. So which is epsilon closure of Q naught comma 0, 1, 2. Which is epsilon closure of in the string 0, 1, 2. I'm splitting it as 0, 1, comma 2. So 0, 1, I'm giving it to Q naught, comma 2, I have kept it aside. So epsilon closure of Q naught, comma 0, 1, already we have computed just now. Okay, epsilon closure of Q naught, comma 0, 1. Ultimately, it is Q1, Q2. You can directly substitute the values here. Epsilon closure of Q1, Q2 on 2, the input. So it is Q1 on 2 and Q2 on 2. Q1 on 2. So Q1 on 2, there is no path. So which is 5. Q2 on 2. Q2 on 2, there is Q2. So which is ultimately epsilon closure of Q2. What is epsilon closure of Q2? The state Q2. What is the Q2? It is the final state. So in our NFA, Q2 is the final state. See. So if you take the input 0, 1, 2, ultimately you are reaching the final state. There's nothing you can traverse more because the input is 0, 1, 2 itself. So I'm taking 0, 1, 2, I'm reaching the final state. So in this way, you need to check whether a string is accepted or not. Only if you reach final state in the last iteration, then only you can call it as a success case. Okay, so try to check as many strings as you can wish for your
So,
practice. Yeah.
So for 0, 1, 1, we are not reaching the final state. So we are going to Q1 and Q2.
Okay.
Like we are going to epsilon Q1 so that the value is Q1 and Q2. No, sir. So we are not reaching the exact final state.
Okay, so you are saying that
accepted,
it's
sir.
okay. Okay. For final iteration, you are getting epsilon closure of Q1.
Yes, sir.
So that is Q1 and Q2 state. So okay, not entirely you are reaching final state, right?
We are reaching the final state, sir, but that is not the final state, no, sir. We need to reach Q2, no, sir.
No, ma. This is not Q1, Q2 merged state as the previous example in the NFA, DFA conversion. This is not, this is two states, Q1, comma
Yes.
Q2. This is not
Yes.
Q1, Q2. So at least you are reaching final state on this input, right?
Yes, sir.
You should reach input over the, you should reach the final state over the input, 0, 1, 1.
Okay, so if we reach like Q1, Q0, Q1, Q2 also, it comes under, we reach the final state, sir. So
Yeah, you can treat it as a one final statement because there is occurrence of final state, right?
yes, sir.
Can you repeat again?
For the string 0, 1, 1, otherwise saying that the final iteration is epsilon Q1. So the states are Q1 and Q2. As Q2 is final state, he is of the opinion that yes, the string is accepted. But some other student, he is of the opinion that as it's not going uniquely to Q2, it is going to Q1 and Q2. You cannot call it as the string is accepted. Okay. I do had a little bit of confusion here now because of this thing. I will just get back to you by evening whether you should call only the single occurrence of Q2 as final or even one occurrence of final is valid. But as far as I have seen the problems, even one occurrence is also treated as acceptance. But okay, just for the safety purpose, I will cross check again once and I will get back to you. Okay, guys?
Okay, sir.
But as for the definition of Epsilon-NFA is considered, at least one occurrence of final state is valid. But just in order to make sure, I will again cross check and I will get, update in the material itself. Okay. Yeah. Thank you all. That's it for today, ma. Happy weekend. Prepare well and all the best for your mid exams. We'll meet again in the next Monday.